Complex 3D models with many constituent parts arise in several important domains, including architecture, industrial manufacturing, and medicine. The kinds of models we produce today are more complex than ever. The problem is, they're so complex that they're almost impossible to comprehend. Existing visualization tools like cutting planes help expose occluded parts, but they do not adequately convey the geometry and layout of the various structures. In this paper, we present a visualization system that uses dynamic cutaway views to reveal occluded parts. Our cutaway illustrations allow the viewer to interactively explore models to better understand their internal structure. Our system incorporates several conventions from traditional illustration for creating effective cutaways. The geometry of a part determines how it is cut. Rectangular parts are usually cut with object-aligned planes. Thin shells, like skin, are cut with windows that reveal hidden parts. Radially symmetric parts are often cut open with wedges, and long tubular parts are typically cut using transverse slices that are perpendicular to the primary axis. From a given viewpoint, occluded parts are also inset from occluding parts to reveal layering relationships. To create the different types of cuts, we construct mappings that transform a small number of cutting parameters into cutting volumes that remove portions of the model via constructive solid geometry subtraction. Varying the parameters dynamically changes the size and shape of the cut. Here we show the mappings for all the different types of cuts that we support. We now demonstrate how a user creates an interactive cutaway illustration using our authoring interface. First, the author categorizes each part as one of the 4 geometric types shown on the right. Here, the user selects the tire and rim, and then hits a shortcut key to label them as radially symmetric parts. In this way, the user quickly categorizes every part in the model. Based on this categorization, the system automatically constructs the mappings for each part. Here, the mappings are visualized in pink. For this model, the entire process takes less than a minute. In a few cases, it may be difficult for the system to compute the desired mapping without higher-level knowledge. For these 3 parts, it is not obvious where to place the axis for creating wedge cuts. In these cases, we have a UI to let the user override the automatically computed mappings. After selecting the parts, he orients them so that the viewing direction aligns roughly with the desired axis, and then clicks where the axis should be positioned. The system then constructs the new mappings by snapping the axis to one of the model's canonical axes and snapping the clicked point to the model's centroid. In practice, this type of manual editing is necessary for just a small fraction of parts. To complete the authoring process, the user specifies good viewpoints for generating cutaway illustrations. Often, the author has enough domain knowledge to identify good views a priori. If not, the author can evaluate a viewpoint by exposing parts using the interface that we show next. Once the model has been authored, it can be explored using our viewing interface. To expose a particular target part, the user just selects it from a list. The system automatically chooses the best saved viewpoint and creates a labeled cutaway illustration that exposes the target. The user can also select multiple target parts. For each set of targets, the system chooses the most appropriate viewpoint. We have tested our system on CAD models as well as anatomical datasets, like the one shown here. If, as part of the authoring process, the user has organized parts into logical groups, the viewer can expose each group in order with a single click, as shown here. During the brief pause after the user selects a new set of target parts, the system chooses the best viewpoint, computes cutting parameters, and determines how to arrange text labels, before smoothly animating to the solved cutaway illustration. In addition to automatically exposing parts, the viewer can directly manipulate the cutting parameters of individual cuts. Here, the user draws a stroke to open up a cut, and then interactively modifies its size and position. Finally, we show that our system can generate effective cutaways of an engine model that contains well over 100 individual parts. In this video, we have demonstrated our system for creating and viewing interactive cutaway illustrations of complex models. Thank you for watching.